Hey kids, Flexing Teacher Weber here. Hopefully you've had a good Easter. Today, Monday, I'm going to get you to do a review of all the math equations we've done so far. Hopefully you've corrected your assignment titled Slow Skier, looked at those corrections, looked at the review notes I've given, and what I've got right here, I'm going to flip to my whiteboard. In the review notes, I gave you sort of 4 examples of the kind you'd have to know. These are the notes I put on Shobi. The key idea to remember here is you always look at the equation, you find the variable, you look at what is beside the variable, and you do the opposite of whatever number operation that is. So in number 1, negative 16 equals x minus 18. Beside the variable, I have a negative 16 equals x minus 28. Beside the variable, I have a minus 28, so I do the opposite of that, plus 28. I have to show that. And if I do it on one side of the equal sign, I do it on the other side, plus 28. Working down the page, I do my calculations now. Positive 28, negative 16 works out to positive 12. Negative 28, positive 28 cancels out, and I'm left with x. Notice how I keep everything on the same side of the equal sign. My x stays on the right-hand side of the equal sign. Okay, so that was a subtraction equation that I solved with addition. Number 2, I put sort of a tricky one here. 7 minus x equals negative 15. Now I find the variable. The variable is there. The operation beside it is actually a positive 7, right? That's a positive 7, even though there's no sign in front of it. So the opposite of positive 7 is negative 7. And I do the same thing to the other side, minus 7. That's not a very good 7. There we go. Now let's see what's left. 7, take away 7, leaves us not just with an x, it leaves us with a negative x. We'll talk about that in a second. And that equals negative 15, negative 7 is negative 22. Now I want to know the value of the positive variable, not the negative variable. So we have to remember, even though I don't see it, there's a negative 1 in front of that x. And I can't leave it as negative 1. That's negative 1 multiplied by x. So I do the opposite. The opposite of multiply by negative 1 is to divide by negative 1. And I do the same thing to the other side. And I get positive x, which is what I want, equals positive 22. Done. Okay, so that was an equation I started off solving by subtraction. Now let's look at number 3. It's negative 7x, which means negative 7 multiplied by x equals 56. I do the opposite of what's beside the variable. Beside the variable is multiply by negative 7. The opposite of that is to divide by negative 7. And if I do it to one side, I do it to the other side. Notice how I show that divide. I show that divide with a fraction. Let's see what's left. Negative 7 divided by negative 7 equals positive 1, x. And 56 divided by negative 7 is negative 8. That's exactly what I want to get. You can leave it like that, or you can just remember that 1x is the same as x. So x equals negative 8. Done. The last one, number 4. It's a division equation. Negative 11 equals negative x divided by 8. Solve it by doing the opposite to both sides of the equation. The opposite of divide by 8 is to multiply by 8. So I'm going to do that to both sides of the equal sign, and I'll do that with parentheses. Multiply by 8, multiply by 8. Make sure you show that multiply by 8 up beside the variable. Let's see what's left. Negative 88 equals negative x. Now we have a situation just like in number 2. We can't just leave it as negative x. Remember, even though we don't see it, there's a coefficient 1 there. Negative 1 multiplied by x. The way to solve this now is to divide both sides by negative 1. And keep everything on the same side of the equal sign. Negative 88 divided by negative 1 is positive 88. And negative 1 divided by negative 1 is positive 1x, or just x. And we are done. Make sure you look at all those examples, then do the review assignment, and we're going to have a test on these kinds of equations soon. Hopefully everything's going okay. Flexing teacher Weber, out.